Hello, space enthusiasts. Welcome back to our channel, where today we embark on an extraordinary journey into the depths of the universe. Our destination? The mysterious and awe-inspiring Coma Cluster, a colossal collection of galaxies that has been pivotal in our understanding of one of the greatest enigmas of the cosmos, dark matter. The Coma Cluster, also known as Abell 1656, is not just any galaxy cluster. Located about 321 million light-years away in the constellation Coma Berenices, this cluster is home to over 1,000 galaxies. But what makes it truly remarkable is that a staggering 90% of its mass is made up of dark matter, a substance that remains invisible yet exerts a powerful gravitational influence on the galaxies within the cluster. The discovery of dark matter. Our story begins in 1933 when the Swiss-American astronomer Fritz Zwicky made a groundbreaking discovery. While studying the Coma Cluster, Zwicky observed that the galaxies within the cluster were moving much faster than they should be, based on the visible matter alone. According to the laws of physics, these galaxies should have flown apart, yet they remained bound together. This led Zwicky to propose the existence of an unseen, mysterious form of matter that he called dark matter. At the time, his ideas were considered radical, but they laid the foundation for one of the most significant fields of study in modern cosmology. Zwicky's hypothesis was met with skepticism until the late 1960s and early 1970s, when astronomers Vera, Rubin, and Kent Ford provided compelling evidence for the existence of dark matter. By studying the rotation curves of galaxies, including those in the Coma Cluster, they found that stars at the outer edges of galaxies were moving much faster than expected. This observation was consistent with the presence of dark matter, which was exerting additional gravitational force, preventing the stars from being flung out into space. The composition and structure of the Coma Cluster. The Coma Cluster is not just a collection of galaxies. It's a dynamic, evolving structure that has provided astronomers with invaluable insights into the nature of the universe. The cluster spans about 20 million light-years across and is one of the richest and most densely populated galaxy clusters known. It contains a mix of galaxy types, including spiral galaxies like our own Milky Way, but it's dominated by massive elliptical galaxies, which are characterized by their lack of star formation and their large populations of older stars. One of the most fascinating aspects of the Coma Cluster is its role in the larger cosmic web, a vast network of dark matter filaments that thread through the universe, connecting galaxy clusters like beads on a string. The Coma Cluster itself is connected to several of these filaments, which serve as cosmic highways for the flow of dark matter, gas, and galaxies into the cluster. This ongoing accretion of matter contributes to the cluster's growth and evolution over billions of years. In 2020, a study led by Nicola Malavasi from Ludwig Maximilians Universität in Germany revealed that the Coma Cluster is linked to three prominent cosmic web filaments. These filaments are channels through which dark matter, gas, and even entire galaxies flow into the cluster. The study also showed that one of these filaments is associated with an X-ray emitting shockwave generated by the collision of infalling matter with the hot gas that fills the space between galaxies in the cluster. This shockwave is a vivid reminder of the ongoing processes that shape the evolution of galaxy clusters. The role of dark matter in galaxy evolution. Dark matter is not just an invisible scaffold that holds galaxies together. It plays a crucial role in the formation and evolution of galaxies themselves. In the Coma Cluster, astronomers have discovered over 800 ultra-diffuse galaxies, UDGs, which are faint, ghostly galaxies with very few stars. These UDGs are thought to be heavily influenced by dark matter, which protects their fragile structures from being torn apart by the cluster's gravitational forces. One of the most intriguing UDGs in the Coma Cluster is Dragonfly 44, a galaxy with a mass similar to that of the Milky Way, but with only 1/100th of the stars. Most of its mass is in the form of dark matter, making it an exceptional laboratory for studying the nature of this mysterious substance. The existence of such dark galaxies challenges our understanding of galaxy formation and raises questions about the role of dark matter in shaping the universe. But the Coma Cluster is not just a passive recipient of matter. It's a dynamic environment where galaxies interact, merge, and evolve. When galaxies fall into the cluster, They are subjected to the cluster's immense gravitational forces, as well as the hot gas that permeates the space between galaxies. This gas, known as the intra-cluster medium, ICM, is heated to millions of degrees by the gravitational energy of the cluster, making it one of the hottest environments in the universe. As galaxies plunge into the Coma Cluster, they are stripped of their own gas and dust, a process known as ram pressure stripping. This process can quench star formation in these galaxies, transforming them from star-forming spirals into quiescent ellipticals. However, the cluster also contains regions where fresh star formation is triggered by the inflow of cold gas along the cosmic web filaments. One such region is the northeast corner of the cluster, where the giant elliptical galaxy NGC 4839 is currently falling into the cluster, bringing with it a supply of pristine hydrogen gas that is fueling new stars. The cosmic web and the Coma supercluster. The Coma Cluster is not an isolated entity. It's part of a much larger structure known as the Coma supercluster. This supercluster spans over 20 million light-years and contains several galaxy clusters, including the nearby Leo cluster. The Coma and Leo clusters are connected by a filament of dark matter and gas, forming a bridge between these two massive structures. The cosmic web, of which the Coma supercluster is a part, is the backbone of the universe. It's a vast network of dark matter and gas that stretches across billions of light-years, connecting galaxy clusters and superclusters. These filaments are the highways along which galaxies and dark matter travel, and they play a crucial role in the large-scale structure of the universe. Recent studies using the Dark Energy Camera, DE-CAM, have provided detailed maps of these cosmic web filaments, revealing the intricate structure of the Coma supercluster and its connections to other clusters. These observations are helping astronomers to understand how galaxy clusters, like the Coma cluster, grow and evolve over time, and how dark matter influences the formation of large-scale cosmic structures. The future of dark matter research in the Coma cluster. The study of the Coma cluster and its dark matter content is far from over. In the coming years, new telescopes and observatories will provide even more detailed observations of this cosmic giant. One of the most anticipated projects is the Vera C. Rubin Observatory, which is set to begin operations in the near future. This observatory will conduct the Legacy Survey of Space and Time, LSST, a 10-year survey that will map the entire visible sky and provide unprecedented data on dark matter, dark energy, and the large-scale structure of the universe. The LSST will be able to detect and measure weak gravitational lensing across the sky, providing a detailed map of dark matter in the Coma cluster and beyond. This will allow astronomers to study the distribution and behavior of dark matter with greater precision than ever before, shedding light on one of the most profound mysteries in cosmology. In addition to the LSST, future space missions like the European Space Agency's Euclid Telescope and NASA's Nancy Grace Roman Space Telescope will further our understanding of dark matter and the cosmic web. These missions will use a variety of techniques, including gravitational lensing, to probe the distribution of dark matter on cosmic scales and test theories about its nature and origin. Conclusion: the Coma Cluster stands as a monumental testament to the complexities and wonders of the universe. It's a place where galaxies live and die, where dark matter exerts its invisible hand, and where the very fabric of the cosmos is woven together by the threads of the cosmic web. As we continue to explore and study this remarkable cluster, we are not just learning about a distant collection of galaxies, we are uncovering the fundamental forces that shape our universe. So, what lies ahead for the study of the Coma Cluster? What new discoveries await us as we peer deeper into its heart and unravel the mysteries of dark matter? These are questions that will inspire and challenge astronomers for years to come. And as we continue to push the boundaries of our knowledge, one thing is certain: the Coma Cluster will remain a key to understanding the vast and mysterious universe we call home. Thank you for joining us on this cosmic journey. If you found this exploration fascinating, don't forget to like, subscribe, and hit the notification bell for more in-depth dives into the wonders of the universe. And remember, the next time you look up at the night sky, know that out there, far beyond the reach of our eyes, lies a universe filled with mysteries, just waiting to be discovered. Until next time, keep your eyes on the stars and your mind open to the infinite possibilities of the cosmos.